Now, coming to the program, of course, we are going through the Python, okay, but still I just wanted to show this one in the R programming language. Of course, I will show you one more program in the Python programming language also. Anyhow, let me just show you. So generally in the R programming language, we usually use the four different types of libraries. One is Caret and GLMNet and MLBench and Psych. These are all different libraries in the R programming language. So now here let us take a look at what exactly that we are trying to understand within this model. Okay. So now here the very first the data that we are trying to use here is Boston. Okay, Boston related data. Let us understand what exactly this Boston related data is all about. It says that Boston housing is not existing. Let us see. There is no package. It is saying that there is no package of Caret and all. Let us install these packages. Okay. We can do this way of installation even. I can give you more something like this. Okay guys, that we have downloaded all these packages. Now let us rerun these packages first. Data Boston housing. We can always try Boston housing data. We can always try. This is the data that within the Boston housing. This is the data that we can take a look at. See crimes, number of crimes and age, the people, the ratio and all kind of stuff. If you wanted to see what exactly this Boston housing consists. So here you can take a look at the Boston housing related data. Okay, and here it is showing you the per capita crime rate by town and the residential land proportion in this non-retail business, Charles level dummy variable, and there are a lot of variables in across here. Okay, and median value of the owner occupied homes, something all the analysis related to the Boston housing. Hmm? So now let us try to validate this particular stuff. Why? Because there are a lot of 500 real observations by this data. Okay, and the source of data and everything has been given and provided over here. Okay, so now I just wanted to make the data partition. Before that, the partition has been done in such a sense like training data and the test data. Data partition is going to be done with the training data and test data done. Okay, and now here I'm trying to control the parameters. Okay, and now I just wanted to make something called a linear model out of this by giving a method is equal to lm for the train. Okay, fitting the final model on the full training set. Now I want to see the results. So you you can see the R squared model for this particular linear model, which is giving you 78.36. What does it mean for the R squared 78.36? Is it a good model or not? We can consider it as a good model either. Okay, and if you wanted to check the results of the ln, and these are the way that you can get it out, and you can also get the summary of your linear model. okay, which will give you more coefficients and all stuff. And finally you can plot this model, and if you can take a look at this one, this is how the plot it will be shown for you. See, you have different plots which you can observe for the given data, different models. Okay, so now let us try to apply the ridge regression for the same. When you are using the ridge regression, you need to use something called the generalized linear model net, a GLM net. Okay, and you have to observe that we have made the alpha is equal to 0 for the ridge regression, and at the same time the lambda value we have given square root of 0.0001 comma 1. Okay, length is equal to 5. Understand? So now let us try to execute this ridge regression, and now we are missing something, and here this is not square, actually this is sequence. I'm sorry, it was a spelling mistake over here, right? So now if you can take a look at this one, I'm going to execute this part now, and this is generating the lambda values. Cross validation is being happened, and it is tuning the parameters. And now let us plot the ridge regression. You can see the ridge regression, how well the repeat due to the repeated cross validation, the root mean square error, how well it is as increasing the regularization parameter, the way it is increased. And you can see the rich results here, guys. And now let us try to fit this model plot. You can see all the coefficients are gradually decreased to become 0, almost 0, but not they are 0. And now let us try to fit this one to understand the factor deviance. And you can see the way that for each and every variable within the data set has tried to make whatever the unnecessary variables have minimized, and the coefficient values have been minimized everywhere. Okay, wherever it is required, it has been kept the values, the importance kind of importance it was given. Okay, and coming to the lasso regression, let us try identifying the lasso regression. You can also plot this lasso regression which you have done. This is how the plot of the lasso regression between the regularization parameter and the repeated cross validation, and you can get the values of this particular lasso. And you can also get summary of lasso, something like this. Okay, so now the final model can be executed, and you can see how you can see the one which is representing the pink in color of the top end line, where it is around the 5 point something, okay, coefficient, where it has gradually decreased it to directly 0. This is not the gradual decreasing of the coefficients to 0, rather we can see how well it has been carried out. Okay, and now, and also you can observe in the lasso regression we have used the alpha is equal to 1, and the lambda sequence is same as how that we have seen. These are the sequential values where it will try to identify from 0.0001 to 1, wherever it is finding good, and it will just choose it and it will go ahead with that. Now let us execute the elastic net regression. Now it is doing all the necessary stuff. And now you can plot this elastic net regression now. This is the elastic net. See, elastic net regression is a combination of both bridge regression and the lasso regression. Hence, you can see the alpha values are 0 and 1, and lambda values has progressed in the same way within a sequence. And you can see the lambda value how it was got normalized. Okay, this is a bit more soothing from the lasso, and which is more nearer for the ridge regression. So this is how the gradually they have explained the fraction deviance from the coefficients part of it, and this is the final plot that you can observe the importance of each and every variable within the elastic net regression. Okay, okay, I hope that you understand this one, guys. But programmatically, we will drive the same example. Programmatically, we will drive the same example in the I mean, in the Python programming also. As why? Because we are giving the more importance to the Python and Python programming. Okay, we will do the Python programming related example in the tomorrow session for the same kind of stuff. Are you all good, Sunil and Suresh? Yeah, alpha value should always be 0 comma 1, but whereas the lambda values, you see I have taken here point not 1. You can take point not 1. You can take point not 1 also till 1, and you can go ahead with a very different length of stuff. Okay, it will slightly change the lambda values. See, it will take the more depth of the lambda values and the processing time, and also it will show you the same kind of graph which is changing in length. That's it. Otherwise, Sunil, everything should be same. Okay, any more questions? We will meet tomorrow and we will discuss about the Python version of the same kind of execution, and discussion about the lasso and the ridge regression. Okay, I will meet you again tomorrow in the morning 8:30. Bye.